Great day, everyone. Today I'm going to share with you some techniques to manipulate FASTQ files again. First, again, you will see what we need to prepare today. Of course, you need a laptop or a computer with at least 8 GB RAM, and then you need some disk space to operate the virtual machine, and then this Oracle VirtualBox and Ubuntu desktop for your work to be run on, and you need to understand some basic Linux command line, and you need to have a good internet connection. Today we are going to see how are we going to filter some sequence reads that are less than 100. Let's say you want to filter some sequence reads that are less than 150 base pair and output it as a compressed file. You want to throw away all those short sequence less than 150 base pair from some long read sequencing platform. In this example, I'm going to use Nanopore because Nanopore can give you at least few thousand base pair for every sequencing reads. So if some of the sequence reads are less than 150 base pair, you might want to throw away these short reads. So to filter the sequence that are less than 150 base pair, we can use two software. First, we can use SEQKIT. Second, we can use SEQTK. I will show to you how are we going to use SEQKIT first. To use SEQKIT, we are using the seq function from SEQKIT. The SEQKIT seq with a parameter -m 150. -m is the length of the short read length of your sequence read that you wish to filter away, and keep all the reads that are more than 150 base pair from a Nanopore FASTQ file. And then we will compress it into GZ file, and we output it as a filter underscore 150.fq.gz. So without waiting, we go to our Ubuntu desktop, the Linux operation system. Here I have already prepared the type ls. I have already prepared some sequencing data here. We are going to use this one, the nanopore.fq.gz, as our working material. So just first we are going to show to you how to use SEQKIT seq. So type followed by seq -m, put a parameter there, -m. You want to filter out all the sequence that are shorter than 150 base pair from this nanopore.fq.gz. And then this is actually a pipeline symbol. After that, you want to further output it as a compressed file, and this compressed file we name it as filter underscore 150.fq.gz. Press enter. There will be a warning message here, but you do not need to bother it. So just this warning message actually just remind you that you can actually put another another parameter -g here to remove the gaps. This one will not after you type enter and run the SEQKIT, there will be some waiting time. I actually wait few minutes, but I stop recording after I run. So there will be some waiting time. Depends on how much, how fast is your computer, and how big is the data size that you are actually running using SEQKIT. We'll have a look on the result, but to view the result, we need to run this to show to you you actually got all the sequence read that are actually 150 than 150 base pair. You have already filtered away the less than 150 base pair. We need to run this SEQKIT. We need to run this one, the SEQKIT, another SEQKIT function, which is actually FASTQ FM. Is actually we are trying to output the FASTQ file or the FASTA file in tabular format. By this we can actually have a clearer view, clearer looks on the length and also the sequence read. So just type before this. We will have a look on the our after we run the SEQKIT to length 50 150 base pair. So just LESS -S filter so the output file, but this output file is in FASTQ format, and nanopore FASTQ read is actually all very long. So from here we are unable to really have an idea of the length. So I will use another function of SEQKIT to show to you that the length of this nanopore FASTQ reads. Just type Q to exit, type Q to exit. So just type SEQKIT. Another function of SEQKIT is FASTX to tag to output your FASTQ file or your FASTA file in tabular format so that you can have a clearer view on the information in it. I want to get the length of every FASTQ file, every FASTQ read. So I put a parameter here, dash length dash name. Every sequence ID dash header. I want to put a header line on our output file. And then from your filter, we put it in a file. Here I just put it as fxlength.txt and then press enter. Let's have a look on the output file of SEQKIT FASTQ for this filter result. So I just type LESS, actually LESS -x followed by the output file name fxlang. So this is a tabular format. The header is here. That is why we are actually specifying header. Now the header, this one, the length, the name, and the length. And we have two columns. The first column is the name. The read names is very long for nanopore sequencing platform. So if we slide to your right side, these are all the length. So you can see that all the length here is actually more than 150. So this one 179 is more than 150. So you can have a look slide down to have a look. See, all the length that we have now is more than 150. All the reads that are less than 150 base pair, we filter it. So just type Q to exit. This is using SEQKIT to perform the filtering action. We have another software, SEQTK. SEQTK to filter. This one, SEQTK SEQ. Functioning looks alike with SEQKIT. So SEQTK SEQ followed by a parameter -L. The length you set is actually 150 also. So I just put there. So in desktop, in our type SEQTK SEQ followed by the parameter we set it as we want to out reads that are shorter than 150 base pair. So 150 from also nanopore fq.gz, and I actually output it as nano 150.fq.gz to show that these are actually from different software. So just type enter. So there will be some waiting time for SEQTK seed to run to filter the sequence read too. So we'll have I actually clear off the screen. So now we'll have a look on the output ls. Our output for SEQTK is this one, the nano underscore 150.fq.gz. So let's have a look. Type less -s nano 150.gz. So again, you can see this FASTQ file, and I will make it as tabular format so that it contains only the sequence read names and also the length of every read, so that you can have a look that we have already filtered out all the short reads of less than 150 base pair. Type Q to exit. So again, use SEQTK. Sorry, is it SEQKIT, SEQKIT, FXTech, FX2Tech, FX2Tech, and then we want the length, we want the sequence read names, and a header. From nano underscore 150, and I output it as fx length 2.txt. So after it finished the running of SEQKIT FXTech, so let's have on the result, the output file, less dash s fx length 2. Type enter. So again, the name of the reads is very long. So just slide to here, the column number 2 is actually the length. So again, you can see all the reads are actually more than 150 base pair. We have already filtered out all the less than 150 base pair short reads. So just type Q to exit. And then after this, we'll see how are we going to change a FASTQ format file into tabular format and vice versa. So just now, actually, we already showed to you how to change the FASTQ format into a tabular format. But that one, we actually specify that we only want to keep the names and the length to show the name of the length. This one, I am actually trying to output the FASTQ format, because we know that FASTQ format is actually a 4-line format. Now I'm going to output all these 4 line into a column format, 4-column format. So you can see that still you are going to use a SX2 tag of a SEQKIT to do this job, but now we are not specifying any parameter, so that we can get a tabular format, a true tabular format of FASTQ file. So again, but this time we are not going to use the nanopore because nanopore read names are too long. So I am going to use a Illumina sequencing reads FASTQ file to show to you how are we going to change the FASTQ file into a tabular format. So this one is actually our SRR X6515554.fastq.gz. Or actually just put there because I already decompressed it. So let's see how to do it. So again, using SEQKIT FX to tag, SEQKIT FX to tag, and then followed by SRR 865, and I want to output it as SRR 865. Here I put it as tag to show it that this is actually as a tabular. Did I Oh, okay, never mind. Still use GZ. I haven't decompressed the file. It is decompress the FASTQ G6 dash D followed by SRR 865 and then press enter. This may take some time. I stop the recording for a while. LS to this. Now we have already decompressed the FASTQ file, the FASTQ.gz to FASTQ file. So let's run the SEQKIT FX tab, FX to tab on it. And output it as .tag. Just wait for a while. So look on the output, just type less dash f srr 865 dot tab. So now you have already output the 4-line FASTQ format into 3-column. The third column is actually just a plus sign, so we did not output the third column. So we have output the first line, second line, and the fourth line as a 3-column format, tabular format. The first column is the sequence name or the sequence ID. The second column is your nucleotide nucleotide reads. The last column is actually your quality value symbol. So this is how do we output the FASTQ format as a tabular format. Just type Q to exit. And then after that, we need how to perform before we had going to perform inspection using FASTQC and MULTIQC. We will see how are we going to convert the FASTQ file to FASTA file. So to convert the FASTQ file, we can use FQ2FA FASTQ to FASTA from SEQKIT. It's actually very easy. Just type SEQKIT FASTQ to FASTA, and then followed by the file name, the FASTQ file name, SRR 8, and then we output it as SRR 8, 86, SRR 86 we will output it as FASTA format. Enter. So it should be very fast. So it's going to, from the 4-line FASTQ format, we are going to output it as our usual 2-line FASTQ FASTA format. Because the file is quite big, so there's still some waiting time here. Okay. Now we'll have a look on the FASTA file that we have already converted. So let's type less -s hrr x.fasta. So you can see that from the 4-line FASTQ format, we have already converted it to 2-line FASTA format. Type Q to exit. And then after that, we have this FASTA file already. If you just want to output certain reads from the FASTA file, you can actually prepare a sequence read list. You can actually prepare a sequence list. Here I prepared this sequence reads already. I keep it as SRR. I keep the sequence list as SRR ID list. So let's have a look on what is inside SRR D list. 2, 2, 2, 3, the SRR blah 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 dot 100 dot 200 and dot 300. Let's say I want to extract or I want to output just these 3 reads from our FASTA file. This just exit first. We can use another function from SEQKIT grep GERP SEQKIT grep to list out or to output certain sequence reads that we want to output. So just type SEQKIT grep and then -f. The parameter is -f, and then the list that you have already list down the sequence read that you wish to extract out. From our SRR x6 FASTA file, and then we output it in my list .txt. So you can see that the software tell you that because I only list down 3 sequence that I want to output, so it says that 3 pattern loaded from file. Okay, let's have a look on our result after we try to output or extract the sequence read according to our SRR ID list. So just type LESS dash S my list. I just list 3 sequence read ID in our ID list. So here is the 3 sequence that I want to get. So you can use SEQKIT grep to output certain sequence read that you are interested in. And then just now you can see that the mylist.txt is actually the FASTA file is actually in a multi-line format. Let's say you do not want the FASTA file in multi-line format. You want to make the FASTA file as a single line format on the nucleotide parts. You can actually use SEQKIT array. Actually a multi-line FASTA. I want to make, let's say I want to make it as a single line format. Sorry, you can use SEQTK, 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 SEQ, and then followed by your my list, and then I put it as my single line .txt, and then type enter. Now you can see that you type that /s and then have a look on the output, my single line. We have successfully converted the multiple line FASTA to a single line FASTA. So you can see here the nucleotide part become single line. So if you want to convert the single line FASTA back to the multi-line format, you can use SEQKIT. Remember, from multi-line to single line, we use SEQTK. From single line to multi-line, we use SEQKIT. So here I want to convert it back to the multi-line format. So just type SEQKIT, SEQ, and then -w. -w. I want to break down the single line FASTA into every line with 60 nucleotides from my single line, and then put it as multi, put it as my list 60, and then press enter. Again, we have a look on our output. Let's my list. So we can see that from single line FASTA, I convert it into footnote, which every line we have 60 nucleotide. Because we are actually specifying a -w60. -w60 means that you want to every line to be have 60 nucleotides. I added a bit our PowerPoint line, our PowerPoint slide. Here I just put my single line. My list. My single line. Okay. And then after that, uh, let's see how are we going to inspect the QC to perform QC inspection of on our FASTQ file. Here I prepare some FASTQ from the sequencing platform Illumina. I prepare it in this MULTIQC folder. This one, the MULTIQC folder. So play into my MULTIQC folder first. You might be using your own sequencing raw data to perform the QC. I'm just using my sequencing data as an example. ILS. So in this folder, in this directory, I have 1, 2, 3, 4. I have 1, 2, 3, 4, 5 sample sequencing data. I have 5 sequencing data. Here 5 pair of Illumina FASTQ file here. So to run the QC inspection, we can use a very famous software named FASTQC. So FASTQC, you can I have already installed FASTQC using Bioconda in the system, so I can directly call out FASTQC, and here all the raw data is actually entered with a .fastq. So to inspect the quality of all FASTQ file in this directory, I can just type FASTQC dash spacing followed by a star.fq. So this means that I want to run FASTQC on all the file entered with .fastq, all the file entered with extension .fq. So FASTQC call the software and then run it on all the .fastq file. So just type enter. I made a mistake here. I cancel it first. Because I do not specify the output folder in the command line just now. If I do not specify the uh, output folder, it will actually output in the current directory. It will be quite messy in this way. So I again rerun the process, but I want to put it in this folder. So I specify a folder. To folder just put -o followed by the directory name FASTQC. I created a FASTQC folder here, see, FASTQC. So I want to output the result in the FASTQC directory. Just type. So it will be start running. take some time, so I will stop the recording for a while. Okay. Now the FASTQC has already finished running on all the FASTQ file that we have. So we'll go into the output folder. From here, ls, we'll go into our output folder FASTQC. So change directory into FASTQC, ls. So you can see that here you will have the .html file and also the .zip file. The .zip file is actually the raw data of running FASTQC. What we are going to be interested is actually the .html file, the web page report format of your QC report. So to have a look on the QC report, because now we are using Ubuntu desktop, you can actually open the .html file using Firefox browser. To open it using Firefox browser, very easy. Just click on the folder here, the file icon here. Click on the file icon here. So click on the file icon here, and then we are actually keeping the result in FASTQC folder. Where is FASTQC folder? It is actually from home. From home we need to go to the sequence directory 2. I actually click here. You might key it as others directory with others names. So I click on my this one, and then I actually add MULTIQC, and then FASTQC. This is the result folder. I will just click on one of the sequencing read HTML report. So this one, the C1F read number 1. So just click open it. Okay. This is the FASTQC report. It will be familiar if you have already sent for sequencing for NGS. So you will be getting this report back. So this is the FASTQC report. So you can see all this QC report diagram here. This is how do we generate the QC report on the sequencing raw data from next generation sequencing or PacBio or even sequencing. So I just close it first. So let's say you have multiple. Let's say you have multiple. I close my. Open it again. Let's say you have multiple results from FQ. You want to combine all the QC report into a single QC report. You want to combine multiple QC report into one single report. You can use MULTIQC. MULTIQC. To use MULTIQC, just go to your FASTQC. I go back to my FASTQC first. So you can see here, you have all the FASTQC.html here. Inside the same directory or the same folder that you keep all the FASTQC report, you can just type MULTIQC. But of course, I can do this is because of I already installed MULTIQC using Bioconda, so I can directly call out MULTIQC. MULTIQC is a software that can combine all your QC report, all the multiple sample QC report into a single QC report. Here we have five sample, 5 pair and 5 pair Illumina sequencing sample QC report. I can combine it into I can combine the 5 pair sample QC report into single report. So I just keep all the report into a directory or into a folder and then just call out FASTQC and then put a dot after MULTIQC and then press enter. It will start running. So you can see that MULTIQC is now running. So very fast, it already compiled the report and then combine it into a single combine multiple sample report into a single QC report. So just type ls. You will see that there will be a MULTIQC underscore data because I performed it already. So the second time I perform it, it put it in a underscore one folder, but this is actually the same. So the folder of MULTIQC underscore data is actually the raw data that we use to generate the MULTIQC report. What we will be interested is the report itself. So again, we need to open this HTML file for MULTIQC report. So open this MULTIQC underscore report.html using the file icon again. Click open on the file icon and then go to MULTIQC data. MULTIQC data. The MULTIQC.html. MULTIQC report.html. So this is the report of MULTIQC. So you can see that I have 5 sample and then 10 FASTQ reads. So we compile and combine all the 5 sample 10 FASTQ reads QC report in one single report. So this is the report looks like. After you run your own MULTIQC, you can actually study yourself in more details. I'm here to just show to you how are we going to combine multiple QC report into a single QC report using this very useful software, MULTIQC. So I hope all of you enjoy this tutorial. It's a bit long, it is a bit lengthy. Thank you very much. So until next time, thank you. If you are interested in any of next generation sequencing, PET biosequencing, and also nanopore technology sequencing, you can contact us by using this email, ngs.bioinformatics.123@gmail.com, and my WhatsApp is also listed here. Feel free to contact us anytime. Thank you.